Basics. So today we're going to be talking about zeros of a polynomial. So earlier, I believe it was lesson 5, we talked about how to multiply and divide polynomials. And with multiplying, I think most people understand why multiplying polynomials makes sense, because you get it in one nice long equation, so that way you don't have to plug in a lot of little stuff everywhere. You just plug in it a couple times and you get your value right away. But with dividing polynomials, I find a lot of students get confused as to why we do that. Why are we dividing? We don't tend to do this a lot most of the time. And the answer is that we do when we're graphing. It's just that we don't do it in the precise way all the time. We don't always do, a polynomial divided by a polynomial all of the time in the same manner that we learn it. So here, when we're looking at zeros of a polynomial, that's going to help us do some graphing stuff, and I'm going to show you kind of what they are and why they're important. So let's start by going to the board for a sec. So a zero of a polynomial. So let's say, let's first say I have my brush. So let's say we have a function that can be written as x plus 4, and then x plus 1, and then x minus 2. So theoretically, this could have been a much bigger function that, we did some division to see what we could break it up into, and so we broke it up into these little parts. So now that it's broken up into these little parts, we want to set this thing equal to 0. So we want to find the x values that give us 0, and that's what I mean when I say zeros. When I say zeros, I mean if x is this number, then I will get 0 for the answer. So cool part about this is that each of these three, so A, B, and C, are all different numbers, but I am multiplying all three of them. So if I set this equal to 0, then that means that any one of these three could be 0 and it'll still work. So if A is 0, 0 times B times C, that's going to be 0 automatically because A is 0. Or if B or C were 0, I'd get the same result. So what I'm going to do is I'm going to set each of these guys equal to 0 and see what happens. So I've got x plus 4, that equals 0. So by that logic, if I subtract 4 on both sides, that means x is negative 4. All right, cool. So then if I do the same over here, so I set b equal to 0, then x plus 1 equals 0. Therefore, x equals negative 1 because, minus 1 on both sides. And so over here for C, x minus 2 equals 0. Same song and dance, different number. Only this time I will be adding 2 instead of subtracting 2. So x equals 2. So I have three values that x could be that would be zeros. So my zeros of this equation would be negative 4, negative 1, and 2. So there's actually three different x values that will give me a y value of 0, which is pretty neat. So kind of like, I believe it was, I want to say it was lesson 4. We talked about how x could be multiple different answers. This is one of those cases where x could be one of three different numbers. So totally fine. It happens. When it happens, we tend to split them up into groups. And this is how you'd find zeros, by the way. You take the function, set it equal to 0, figure out what your zeros are. So this is how you do it algebraically. So, do synthetic division, split it up into its factors, and then once you have factors, set them equal to 0. Stuff like that. However, there is another way to find them because, as I've tended to do a few times, we like to do things quickly and efficiently. So now we're going to talk about not just finding zeros of a polynomial, but how to find them quickly. So the two ways to kind of do it are to graph it or to factor it. So we'll do factoring at the end. But for right now, what we're going to do is we're going to go ahead and graph it. So give me 1 second. So we're going to switch over to the chart. And this time I actually have, so not something that I'm going to draw specifically, but we're going to go over to Desmos. So we got an example pulled up over here on Desmos. So Desmos has graphed a function for us. We don't know exactly what function it is, but what we do know is we know where the y value is 0. So the y value is 0 along the x-axis. So if we want to know where y is equal to 0, all we have to do is look at the points where the graph crosses the x-axis. So over here, so when x is equal to negative 5, that's a 0. When x is equal to negative 1, that's a 0. And when x is equal to 3, that is also the 0. So now, The thing is, though, we don't know what this function is exactly. So what we're going to do is we're going to use these answers to create the original function. So since x is equal to -5, that would mean, so if I added 5 to both sides, so add 5 to both sides, that would mean that x plus 5 equals 0. And as we just said, so earlier, if we have to set it equal to 0, that means it's a factor of the function. So x plus 5 is in there somewhere. And if we go over here with x minus 1, add 1 to both sides, so add 1. So you get x plus 1 equals 0, which means in here we'll have x plus 1 as a factor. And then over here with x minus 3, we are going to subtract 3 from both sides. So minus 3 minus 3. So x minus 3 equals 0. So x minus 3 is another factor of this function. So if I needed to make a function, and I was just given this chart to look at, I would look at where the zeros are, and then I would try to get, x plus or minus whatever equals 0. Those are going to be the factors of that function. So if ever you get a graph and you need to make the function using the graph, well, there it is. You know exactly how to find it. And of course, if you wanted to check specific values, you could. So like if you wanted to plug in -3 and see what the y value is, I want to say that's somewhere around 23. I want to say that's around 23, probably closer to 24 or 22. But somewhere in that area, you could plug the x value into this function and then see if the y value matches up. So if you needed to make the graph, you could do that. And then if you needed to make the function out of the graph, you could do that. And if I just gave you the graph, you could point at the zeros as -5, -1, and of course 3. It's actually quite easy to just quickly go, oh, okay, so there's an x at 0, there's an x at 0, there's an x at 0, and then bam, there you go. All of your zeros all tied up in one place. Oh, wrong button there. My bad. Hold on one sec. There we go. Sorry about that. That was a bit strange. Well, actually, I need to fix this one sec. So now we're going to switch this back over to the whiteboard. There we go. Sorry about that. Now we're back on track. Okay. And so that's one way to find the zeros of a polynomial. But the other way that we could find the zeros is to factor our polynomial and set it to 0. So what I'm going to do is I'm going to go, and I do have a specific example of this. So what I'm going to do now is we are going to go to the board, and we're gonna grab one that looks kind of ugly, and we're gonna make this work. So we're gonna have the functions. So it's like f of x is equal to, so let's say x cubed minus 9x squared plus, and then we're gonna have 3. Oh wait, no, not 3. Sorry, this should be 9x minus 81. Okay, so we got a function. It looks like this, and obviously this is kind of messy. So a couple options that we have is we could go into synthetic division and just try to guess some numbers, try to see which ones work. But for something like this, we actually have a different kind of strategy for this one, and that's why I wanted to do this one specifically. So we can actually section off this problem into 2 parts. So we've got the x cubed minus 9x squared, and we've got the 9x minus 81. So what we're going to do is we're going to try to find a number to remove from both of these. So we're kind of reverse distributing, if you will. So both of these terms have an x squared that they can give up. So if they can both remove an x squared. So if we remove an x squared from both of those terms, we're left with x minus 9, which, that's perfectly fine. That's good. We can do that. So then for these guys over here, both of these guys can be divided by 9. So I'm going to do that. So I'll get 9, and then I'll get x minus 9. So the cool part about this is, so we've removed a little something from each term. But now what we're going to do is we're going to notice, hey, wait a second. Both of these guys are multiplied by x minus 9. So just like before, where both of these terms were multiplied by x squared, and both of these terms were multiplied by 9, we are going to take away the x minus 9 because it's multiplied by both terms. So what's left over, so if we remove that from the equation, because we factored it out, all we're left with is x squared plus 9. Okay, so now I can just set both of these to 0. I can find my answers. Okay, cool. So let's do those guys. So we'll start with x minus 9. So if x minus 9 equals 0, we add 9 to both sides. And then x equals 9. Awesome. So then, now we just got to do the other one. So now for the other one, we do x squared plus 9 equals 0. So that would mean x squared equals a negative 9. Okay, so this is the point where we can't really get any zeros out of this, because if we do the square root of both sides, we get x equals the square root of negative 9, and that is not a real number. So we're going to say not a real number. And bam, just like that, we know that the only one we can get out of this guy is positive 9. Now, if this would have been x squared equals 9, well, then the square root would have been 3 and negative 3, and then we'd have negative 3, 3, and 9. But in this case, the only one that's working here is the x equals 9. So we're going to say x equals 9 is our only 0. And, you know, sometimes if you just don't get zeros after you factor it, that's okay. That just means that they're not ones that you have to worry about. They're not a real number. So you don't got to worry about them. So those are the two ways to kind of quickly find the polynomial, or the zeros of a polynomial. I would recommend going ahead and graphing, just because, you know, it's a bit faster, it's a bit easier, it's a bit more convenient. But not every professor wants to let you graph, so, you know, you can always use your, your factors in order to do that. And that is going to be it for the zeros of polynomials. Next time, we're going to be talking about functions in general. So we've already talked a little bit about them, but we're going to talk a little more about the properties of functions, how they work, and things like that. So for now, we'll leave you off on this, which is the question I'll be going over in the synchronous hours. We already did something kind of a little bit like this, but these numbers are different, and of course, so I want you to go ahead and try it on your own. See if you can write that equation and then compare it whenever we meet for the synchronous hours. So in any case, I will leave you with this in the independent practice, and I will see you in the next one. Bye-bye.